Hello everyone and welcome to my channel, where I share with you everything you need to know about water quality and filtration. In today's video, I'm going to answer a common question that many of you have asked. What is the difference between water turbidity and SDI? These are two important parameters that affect the performance and efficiency of reverse osmosis systems, which are widely used to produce clean and safe water for various applications. So let's get started and find out what they are and how they differ. Water turbidity. Water turbidity is a measure of the amount of suspended solids in water. It is expressed in nephelometric turbidity units, NTU, which indicate how much light is scattered by the particles in the water. The higher the NTU, the more cloudy or murky the water is. Water turbidity can be caused by various factors, such as soil erosion, organic matter, algae, bacteria, or industrial waste. Water turbidity can affect the aesthetic quality of water, as well as its taste, odor, and color. It can also interfere with the disinfection process, as the particles can shield microorganisms from the effects of chlorine or ultraviolet light. Water turbidity can also affect the performance of reverse osmosis systems, as the particles can clog the pores of the membrane and reduce the permeate flow and quality. Therefore, water turbidity should be reduced before reverse osmosis by using appropriate pretreatment methods, such as coagulation, flocculation, sedimentation, or filtration. The recommended turbidity level for reverse osmosis feed water is less than 1 NTU. Water SDI. SDI stands for Silt Density Index, and it is a measure of the fouling potential of suspended solids in water. It is calculated by forcing water through a 0.45 micron membrane filter at a constant pressure of 30 psi, and measuring the time required to collect 500 milliliters of filtrate at different intervals. The SDI value is then computed using a formula that takes into account the initial and final flow rates and the elapsed time. The higher the SDI, the more likely the water is to foul the reverse osmosis membrane. SDI is not the same as turbidity, as it does not measure the quantity of particles, but rather their size, shape, and tendency to adhere to the membrane surface. SDI is more sensitive to the presence of fine particles, such as colloids, iron oxides, or organic matter that may not be detected by turbidity measurements. These particles can quickly reduce the membrane flux and increase the differential pressure, leading to frequent cleaning and reduced membrane life. Therefore, SDI is a more reliable indicator of the need for pretreatment than turbidity. The recommended SDI level for reverse osmosis feed water is less than 3. Difference in both. To illustrate the difference between water turbidity and SDI, let's look at some examples of water sources with different values of these parameters. Seawater typically has a low turbidity, as most of the particles are dissolved salts that do not scatter light. However, seawater has a high SDI, as it contains many fine particles, such as organic matter, bacteria, or plankton that can foul the reverse osmosis membrane. Therefore, seawater requires extensive pretreatment, such as media filtration, cartridge filtration, or ultrafiltration, to reduce the SDI before reverse osmosis. On the other hand, surface water, such as river or lake water, typically has a high turbidity, as it contains many large particles, such as soil, sand, or clay, that make the water cloudy. However, surface water may have a low SDI, as the large particles can be easily removed by simple pretreatment methods, such as coagulation, flocculation, or sedimentation, leaving behind water that is relatively free of fine particles that can foul the reverse osmosis membrane. Therefore, surface water may require less pretreatment than seawater, depending on the quality and quantity of the particles. As you can see, water turbidity and SDI are not directly correlated, and they have different effects on reverse osmosis performance. Conclusion. In conclusion, Water turbidity and SDI are two different parameters that measure the amount and the fouling potential of suspended solids in water, respectively. They are both important for water treatment, as they affect the quality and the efficiency of reverse osmosis systems. Water turbidity can be reduced by using various pretreatment methods, such as coagulation, flocculation, sedimentation, or filtration, while SDI can be reduced by using finer filtration methods, such as media filtration, cartridge filtration, or ultrafiltration. The recommended levels of water turbidity and SDI for reverse osmosis feed water are less than 1 NTU and less than 3, respectively. I hope this video has answered your question and helped you understand the difference between water turbidity and SDI. If you enjoyed this video, please give it a thumbs up and subscribe to my channel for more water quality and filtration tips. And don't forget to leave a comment below and let me know what other topics you would like me to cover in the future. Thank you for watching, and I'll see you in the next video. Bye for now.